Hello and welcome to the Entopy webcast. Today we're going to be talking about our AI agent. Very specifically, we're going to be talking about scenario and analysis testing in complex operational environments. So how does LLMs provide this sort of analysis and scenario testing capability within the entire unified intelligence stack? I'm joined by Dan and Gauss for today's webcast. So thank you guys very much for being on. We actually introduced the AI agent via a webcast pretty much a year ago, roughly around the same time last year. And so much has happened in the sort of past 12 months. It's advanced immensely, to be honest. It's pretty amazing. But I think the biggest thing is the clarity over how we're going to use LLMs in this context. And this, I think, is a question that a lot of people are grappling with, right? Everyone can sort of acknowledge, or everyone does acknowledge, that AI, or what most people call AI, which is large language models, is an amazing technology and it's going to transform everything. But I think what people are struggling with quite a lot is how. How do these technologies live inside my organization? What capabilities do they provide me in my role? And how can I use them to deliver business value? And I think the biggest kind of achievement over the past 12 months has been our clarity over what that looks like in our world. So we have two very distinct agents. We talk about them separately. So the first is the one that we're not going to talk about today, which is the always on agent. So this is something that watches the digital twin and sort of proactively communicates issues to operators. The second is there as a strategic tool, and it's there to support senior decision makers within an organization to make strategic and transformational decisions. It could be tactical decisions, but it's designed to be episodic. So that's the agent we're going to focus on today. And we're going to kind of go through it in a bit of detail and pick out some of the things. So before we go into that, just a couple of very, very quick announcements. This webcast comes fresh off the back of Entopy being named AI SME of the Year in the 2026 National AI Awards. And it coincides with the relaunch of our website. So we've, given it a bit of a glow up, if you like, and you can go on there and find lots of key resources and learn about what we're doing at Entopy and read about some of the examples of where we've deployed unified intelligence successfully and the results it's sort of had. So I'd encourage you to go and have a look. But for today, let's go straight back into the webcast. So Dan, if I can come to you first. So I mentioned in my opening that we've built a lot more clarity over exactly how we want to use language models, what role they play, I suppose, within what we're calling unified intelligence. Mention the always on, but for the strategic agent, as we call it, I suppose it has a couple of core functionalities. Would you mind just describing that in sort of simplistic terms for our audience?
Yeah, so we kind of run it in two separate modules, if you like. We have an analysis agent and a scenario-based agent. So the user analysis, again, kind of says what it says. It's run an analysis over historical data. And it can sometimes use predictions as well, but it's mainly about analysis. Whereas scenario is saying what's going to happen, what would happen if I change this in my environment, for example. And it can use the digital twin data along with domain knowledge and stuff that's built into that agent to be able to give them sort of answers.
So is it fair to say that deep analysis is using data that I suppose we could class as real or has been derived somewhere else? So it's either real data, it's observed data, or it's predictions from models, and scenario is potentially maybe using some of that, but it's talking more about hypotheticals.
As Dan said, analysis, as deep analysis basically is you want a report to be done. You want to see how the port has done in a couple of months. What's the financial impact, or can you improve anything else in the port? Basically, can you bring in a vessel? If you increase the tugs more, is it going to improve the operational value of the port? And scenario, whereas is it keeps you prepared. Okay, if something goes wrong, what can be done? and it's basically like what if scenario. Basically, it tells you, okay, if there are less crew members, can something go wrong? If a crane fails, can something go wrong? It just keeps you prepared for the future. It uses historic data and sometimes live data if it wants to. And deep analysis is the same as Tan explained. Like it uses the digital twin data, which is live basically. Yeah.
So and one of the things that we spoke about in the last webcast when we introduced the agent was that our big thing was that we have this unified intelligence layer, we have this digital twin, the world model, if you like, that's continuously updating, and the language models that we're developing, the agents that we're developing, are plugging to that basically. So they've always got this continuously updating operational picture, and they can do some analysis. So if I'm a strategic decision maker in critical infrastructure, so I'm in ports, maritime, I'm in logistics, I'm in rail, I'm in aviation, I can go and speak to this tool that looks very similar to a chatbot, like what most people would be familiar with. And I can either ask it to do some deep analysis on the previous week or the previous month, and maybe within that analysis ask it how I can improve certain things or where there are opportunities. Or I can put it into scenario mode and say, we've got bad weather coming in next week. How is this going to affect us, and what are my best mitigation strategies? Okay, so this is designed to drive quite important decisions. Then, so this is quite a high bar we're setting ourselves. So people might be familiar with things like ChatGPT or Gemini or Claude hallucinating. This can't do that, otherwise it's as good as useless, right?
Yeah, no, that's exactly right, and we've had to combat that by. There's lots of validation steps we have to run. There's lots of actually talking to the customer as well, getting that human in the loop so we can build domain knowledge into the system. Running it, it's not just, like, lots of people will run this, they'll just dump lots of files into an LLM, basically, and just get it to run over all that. That's where hallucination will come in, because you're running into context, windows, issues, and all that stuff. So we can't run it like that. So every single question probably runs through 100 different steps to ensure that doesn't happen.
So maybe just to unpack that a little bit, because just before this webcast, I said to you, what's the hardest thing that we've had to overcome over the past 12 months? And you very, very quickly, without a second thought, said accurate data retrieval.
Yeah, most definitely.
So, but before anything else, accurate data retrieval.
Yeah.
Otherwise, everything else is gone.
Yeah.
So, and you said it goes through 100 steps or so.
Could be more.
So without going into too much detail for obvious reasons, let's say that I ask a question of the agent. Let's use a port example. So I want to know what the over the next 7 days, what are the highest risk vessel movements that are on my roster for the next 7 days? Just give me a flavor of what the agent would be doing to answer that question.
Yeah, that's it. So it'll be, first thing, when in its reasoning, it'll be splitting down that question into multiple different questions of what I need to ask for here. What data do I need to answer this question?
Okay.
So it'll go in and see what's scheduled, what could come ad hoc based on the past.
Yeah.
What's weather going to be? What's the tides going to be in this case? What's the crewage like? All that sort of stuff. What's the utilization of the berths? How's the berth performing? So it will take all that into account. But it won't just do it once. It won't just do that once. It will be individual things querying each of them.
So one agent is going off and getting berth utilization. One agent is going off and getting weather.
Exactly. And then they're all coming back together. Each one of them is then validated.
How's it validated?
It's another agent on top of that, which goes through and validates that.
And would that be the same model, or would that be a different model each time? Does it matter?
No, there will be the same model each time, but that's our validation agent, basically, that will validate that.
Okay.
We might have slightly different ones, for different aspects, but mainly the same one. And then in terms of how we build micro models, it works a very similar way of our agent. So we now have packets of data. So then we start to build that packets of data into more reasoning.
Okay, so all of these agents have swarmed over the database, presumably.
Yeah, databases, and not just a database. It could be external APIs. It could be internal APIs.
Okay.
It could be files, but not very often.
And just on the database point, because and I'll come to you in a second, Gauss, but just on the database point, this is a really important one. So again, we're working in critical infrastructure, data security, sovereignty, privacy, really, really important. How do we allow a language model to go and interact with data from a database that is effectively the digital.
So the agent never touches the data source.
Okay.
We have written pieces of middleware, if you like, which are run by us, which go and retrieve the data based on what it's asking for.
And that's like a proprietary layer.
That's a proprietary layer, yes. So it never has raw access to any data source.
And that's a very big step.
Yeah.
Okay. And so you've now got all of these agents swarming all over the place to try and pull various bits of information. Question for you, Gauss, I suppose. Well, there's two questions and you can answer them in whatever order. The first question is, why do we split them into lots of small things to go and get specific bits of data? Why don't you just get one agent to go and do it all? And the second question is, presumably another agent now has to sit there and put all of those bits together. Again, why do we separate that process out? What is the benefit to modularizing this?
Right. So if there's a question and if you're doing a deep analysis, as a human, if we have to make a decision or if you have to answer some question, what we'll do is we have to split into smaller part. We have to modularize it so that it can answer
subtasks.
Exactly, so that it can answer every question and we get detailed information. Right. If just I ask a question, okay, if any question, if I just ask it, it's gonna get a data. It's gonna get the data from the database. It's gonna retrieve perfect data. That's how we have built the agent. That's not an issue. But we need answers for every, like we need a detailed answer. There could be, if you ask what are the financial impacts of having two berths closed. If you have two berths, if you shut down two berths, what will be the financial impact on that? Now, if we can get the berth data, we can get the financial data, we can analyze it, done. But our agent, it divides that question into sub questions so that every berth, every vessel is taken in account for. Everything which is like.
So it's like improving the odds of getting accurate.
Yes. On top of it, we get an overview of the whole question and data which we have, which it can use. But we have limited it to a certain sub question so that it does not just scatter around and gives us data which we don't.
So that you have put some control on how far it can go.
Yes, exactly.
But the idea of splitting a very complicated question down into smaller bite-sized chunks, going and answering those bite-sized chunks, and then bringing it all together to compile the answer.
Exactly, that's right. And the second question was...
The second question is, I suppose it is linked, but why do you have a separate agent, or is it a separate agent that's then bringing all of these things together? And why is that separate from the agents that are going off and getting the information?
Right. So we get the information. As soon as we split the question, and I've said, like, we have to validate the answers. We have to validate which data are necessary, which data are not needed, basically. That agent does that work. Once we get the data, the other agent sits on top of it so that we know this data is required. This data is like connected to the question which has been asked by the user, and then we give answer. We give back the answer to the user. We cannot give all the data because then the hallucination starts.
And Dan, I suppose it's also got something to do with where you want the LLM to do reasoning and things like
Yeah,
this,
most
right?
definitely. So having smaller sub questions, firstly, your data is going to be more accurate.
Yeah.
But then it will do reasoning upon that sub question.
Yeah.
Whereas if you was just doing it from the top level, there's only a certain level of reasoning it will do. Do you see what I mean?
I do.
So you can break that down to sub questions. It will do reasoning and that on that sub question. So you bring that all together. And also when you're pulling huge amounts of data, you're going to run into context memory issues, context window issues. So in order to do that separate and then bring that together as an output, you can immediately knock off 10 times the amount of context.
Okay, so it's about managing context, so how much information is being processed each time. And just for the audience, just to, because there's a lot of jargon that starts to come through. So a context window is basically the number of tokens an LLM can process in one query. The way I think about it is, as a human being, you have a limited amount of information that you can retain and process at once, right? If you had the last 30 years of your life thrown at you, your head would explode. I always say that it's a bit of a turn or a bit of a quip, but it's basically the same thing. And most LLMs are currently working on about 1 million tokens, right?
Roughly, yeah.
If you put more information in than that, the query won't work, or it will take a bit of it to get it down to its limit, and it will start hallucinating and not giving. So that has really, really careful management.
Yep.
But it's not too dissimilar to our own ability to process information.
No,
so
right.
I always like to draw the parallels with human thought with these things, not because I'm a, not because I'm trying to scare people or anything like that, but it's just it's a logical way of thinking, a bit like how you said, break these down into sub questions and so on and so forth. There was a thread in there. I've lost my trail of thought, but you were on a path talking about reasoning and how you actually don't want the things that are going off and getting information to do too much reasoning.
No, that's right.
And you want the reasoning to be sort of separate for that. And we're in a World Cup year, so I suppose it's a bit like having Messi playing centre back. You don't want someone doing pirouettes in front of goal.
No, exactly. Yeah, and it is a lot like that. So you'll have a much lower level of reasoning in certain aspects, and that's just in our architecture, compared to others where you'll have a higher level of reasoning.
Okay, so if I'm asking a question and I'm receiving a response back from this agent, analysis or scenario, I can be sure that the process that it has gone through to get that information is solid and robust, and has been through multiple steps, hundreds of steps often, to make sure that that's accurate. And we don't then stop there, do we? Because we then do live tests with end users, with customers. How are they going?
Yeah, so Dan deals with the customers mostly.
Yeah.
So
Dan, Dodge.
No, yeah, they're going really well. The customers are giving us great feedback.
Yeah.
And then any other feedback that we need to build onto, we're doing. But yes, some of the feedback we're getting is phenomenal.
And to be clear, the level, the bar that we're operating at, and we are comfortably operating at this now, is can I use this report to drive a board decision?
Exactly. Yeah.
Can I use this to drive a financial decision? And that means if you ask the same question twice, it has to give you the same answer, or at least make sure that it's working off the same assumptions underneath prior to reasoning.
That's right. The facts. So the facts always have to be correct.
Yeah.
If I asked you a question, if I asked Gauss a question, you'd give me the same facts, but the way you word the answer would be different.
Yeah.
And that will happen, but the facts have to be the same.
And the explainability within it, I've seen the outputs that come from the agent and scenario, and it breaks it out really, really nicely in terms of here's your answer, and then here's how I got there.
That's right, yeah.
And it gives a lot of detail. So that's all fantastic. And we haven't really spoken about ontology, but the ontology has a really important role to play as well.
Yeah, most definitely. So it needs to understand key relationships and stuff like that when it's querying data. So when it's building a query, it needs to be able to understand where else the data could be obtainable from.
So again, it's just an opportunity, but we use the word ontology a lot in how we talk about unified intelligence. It's foundational to it. It's foundational to digital twinning. It's foundational to making LLMs useful. And is a good way to think about the ontology effectively the map of the database. So this is, if you have a question that relates to this, and this is how that translates to what the how the data is structured and stored.
Yeah, that's right. That's a good way of thinking about it.
Yeah.
In a easy
Very
way.
simplistic way.
Yeah.
Very good. I'm going to move on to the next part then. So when we're doing, so we've spoken about making sure that the data that comes back and the data that is ultimately analyzed, and when we're accessing the reasoning powers, the reasoning capabilities of language models, which is phenomenal, we're making sure that they're reasoning over, trusted data. We know that's the data that we want them to be reasoning over, and we're limiting reasoning in certain areas. It's also important to say we're model agnostic, so we can swap in and swap out. But there's a couple of other tools, Gauss, you've been kind of the main driver for these, that make things like scenario and deep analysis really powerful. So the first one's cascading impacts. So would you mind just very briefly summarizing what cascading impacts is, or what the objective was? Why have we built a cascading impacts engine?
Cascading impacts can be taken as a butterfly effect, where one thing can affect the whole port.
Okay.
Or it may not affect as well. We cannot just say it is going to affect eventually.
Yeah.
But we need to find out, will it affect the port? Is it going to affect financially? Is it going to affect the operational value of the port? Or is it going to affect crews, crane, whatever comes in on the vessels.
Yeah.
So cascading impact takes into consideration there are different orders of cascading impacts which we do basically.
Yeah.
So the first order cascading impact which we see is what are the major impacts, what are the major things which will cause an impact on the port.
So this is first order.
First
So
order.
an event has happened.
Exactly.
And that event is going to have an impact somewhere. And
That's
it's not
right.
just ports, it can be airports, it can be any critical infrastructure.
critical
This is
infrastructure.
designed for critical infrastructure environments
right.
where you've got lots of operational dependencies and so on.
That's
so
right.
we have an event that's happened, so bad weather, or a delayed vessel,
Right.
or a delayed flight, or a traffic jam, or a car incident, or something like that. That is an event that has a first order impact.
That's right. As you said, like bad weather can affect both airport and ports. A bad weather can cause disruption for customers, even in the port or at the airport.
Yeah.
So that's we take as the first order cascading impact. Then we go to the second order cascading impacts, which are basically because of the first order cascading impacts, or just suppose weather. What are the second order cascading impacts? Which other things are gonna get impacted after that?
So it would be something like first order impact means this vessel cannot have a pilot board it.
That's right.
The second order impact says, okay, what's the impact of the pilot not boarding that vessel at the planned time?
That's right.
Okay.
Yeah, so that's second order cascading impact. As a human, we can think until third order cascading impact. Okay, what are the other effects? But as soon as you go for fourth and fifth order cascading impact, it just goes like a graph. It's just like downstream graph where basically everything is going to affect other
Beyond our comprehension.
Exactly. So for that reason, why we use machines, why we need agent, where it will think, okay, this is the first order cascading impact, this is the second order cascading impact, which keeps you prepared in case something happens.
And what you've built over the past however many months, but you've been working on this for, it's been a really, really big undertaking, and it continues to get better. But what it essentially does is it works out first, second, third, fourth, fifth, sixth, etc. order impacts from a single event.
Exactly. And so you can use it in a way where you can improve your operational efficiency. You can improve your financial efficiency. You can improve customer efficiency. You can improve in every other way. So we can think until second, third order.
Yeah.
After that, we cannot.
Well, I'd argue we'd struggle past second.
Second, exactly.
To be honest,
Yeah.
to get it accurate. And we're going to have another webcast on operational and situational memory, which is a big part of that. But I can see how cascading impact plays very, very well into deep analysis and scenario testing. The second thing that we've worked on, that you've both been working on, is wargaming.
Yep.
So, Dan, can you explain to me what wargaming is?
Yeah, so wargaming is when we have teams of attack and defense against the data.
Okay.
So a good analogy is sparring in boxing. Both professional boxers sparring against each other. They're both attacking, they're both defending each other, but they're not trying to kill each other. So that's the key thing with wargaming. One of the agents is not trying to kill the other one. It's about, I'm attacking this and I'm defending. And to find the weak points in the logic, or to find the weak points in that. Same as sparring when you're boxing.
Okay.
The end goal for a boxer is to get ready for a big fight. The end goal with the wargaming is to make sure that the answer is the best it can be.
Can withstand scrutiny.
Exactly, yes.
So, and people will be familiar with wargaming as a concept.
Yes, oh yes, most definitely.
So red team, blue team, it's a very, very old practice.
Yeah, of course, yeah. It's very much like you'd use when you're doing hackathons and stuff like that. It's very much used in that way.
But we're using LLMs to do this, which is quite novel. It's actually a bit of a trend at the moment. There's a lot of people that are trying to work towards this. But we have seen pretty amazing results. So maybe, Gareth, if I come to you on this. So a question comes in, or I ask a question of the agent, and it's a scenario. And the scenario is that we're going to have a particular event that is going to affect, we're going to focus on ports again. So it's going to affect landside operations. It's going to slow everything down there. It's going to affect, it's a very, very bad weather event. So it's going to affect landside operations. It's going to affect pilot stations. So it's going to affect boarding. It's going to affect some navigational aspects as well. And and I want to understand how I can recover the impact of that plan. So it's gone, the agent has gone off and retrieved all of the information that it does. It's gone through the 100 odd steps that you've mentioned. It's all been validated. It's all come back. We're happy. It's used the ontology to understand what it needs to go and get, and then it's gone and retrieved it, and it's then reasoned. It's got an answer. That answer includes cascading impacts. So it's got the first, second, third, fourth, fifth order impacts of the bad weather event. And now we've got an answer. Introduce wargaming. So now what happens?
So now, as soon as we get the answer, we let LLM decide, and basically we decide. We tell LLM, okay, these are the important factors which can cause disruption in a port.
Okay.
It chooses different. What you can say is like it'll choose how many tugs are there and what disruption can tugs cause. What disruption can a vessel, which is mega max vessel, will cause to the berth. What disruption a pilotage will cause. There are different disruption which can be caused. So every disruption is then sent to an agent, and that agent decides, okay, if this happens, if there are only less tugs, can this vessel berth? Can we berth this vessel? Is it possible? Will there be any delay? If and but and what if, these kind of scenarios happens.
And it picks the top assumptions that it's seen you make in that answer that you provided, or the first answer that's come up. It picks, okay, so that answer is based on these assumptions, or it's already got a bit of a world model and understanding of what the likely assumptions are going to be.
Yeah, the assumption comes from cascading impacts, which basically filters out, which are not causing more disruptions.
Okay.
So
Okay.
So that's how. So once we filter out all these disruption, causing anything which causes disruption, or which are not causing disruption. So the things which are causing disruption are the important factors affecting the port. Basically, we pick that up, and then we create what if scenarios, wargaming basically. Which
and that's when it says, okay, this is your current resource that's in that answer, but if we were to change that to this, what happens?
Exactly.
If we were to change this to this, what happens?
And also, it also depends on the historic data, what has happened.
Yeah.
Which is present with us, and it just picks it up as well, and it learns, and then it provides an answer.
Yeah.
So what you're going to cover in another webcast in terms of operational situational memory, it has to use those tools as well to understand, oh, this has actually happened in the past, so we can see a path to resolution, or to see where the bottlenecks were, so it can use that data as well. But you'll cover that.
No, it's brilliant, guys, and I think we can just start, because we've covered a lot, and we try to keep these relatively on point, these webcasts. But if I'm asking a question of deep analysis or scenario, I can be confident that it's going to be working off accurate base data. It's going to be reasoning, and it's going to explain what it's reasoned about. It's going to have a cascading impacts engine which sits alongside, that benefits from memory and so on, but ultimately is it's specifically designed to do the job of working out first, second, third, fourth, fifth order impacts. And then once an answer has been produced, it's then wargamed, and it provides all of that analysis in the answer that the user ultimately receives. So they get the top answer, and then they can see what has been tested, what has been wargamed effectively.
Exactly,
Keeps them prepared for any scenario.
It just builds the trust in the answer. Exactly. I mean, we're talking about really quite significant questions people are asking of these things now. In the past, they'd have gone to a consultancy or like, and spent hundreds of thousands going through this wargaming tabletop exercise. It's just, I think it's absolutely remarkable that one person can now do it in their office.
In 20 minutes.
It's absolutely phenomenal. So on that, I think we'll bring it to a close. Are there any final comments from you, Dan?
No, it's all good.
Any final comments from you,
it's all good.
guys?
Thank you.
Brilliant. Well, thank you both very much for your time. Thank you all for listening. We'll see you all soon.